Sorry, I was muted. Hello. Sorry, I'm a little
Hi,
bit
how are
late.
you?
Yeah, doing good. Cool. Thanks for joining. I will be asking you to share your screen later on, anyways,
Okay,
as we're doing the coding portion. Just FYI.
sure.
But yeah. What I have planned for today is basically a 1 to 2 coding question format.
Okay,
Um, that will kind of span over a course of approximately 45 minutes to like 50 minutes, and then um, I'll basically save about 5 to 10 minutes at the end for questions and feedback.
sure.
Just open up the codebook link. I think that'll provide you right with the Zoom link.
Yep.
Set the language to your preference, share screen, and then we can jump right into it. Let me grab the question. I'm going to read it out to you, give an example, and then the rest of the time will be up for you. Let's see. Yeah, for today, we're going to be dealing with binary tree.
Okay,
And basically what I want you to do is return the two closest elements, placing value within the tree. So given this sample example of these three nodes,
yep.
they're basically return 1 and 4.
Got it. Okay. Yeah. Cool. Okay. And then I'm guessing, is it all right if I type in this like comment section as
Yeah,
well?
yeah. The
Okay.
rest of the time is up for you. So yeah, feel free to type anything, change anything. Yeah.
Okay. So if it was like, let's see here. Oh, Uh, so if I guess just to clarify, I just want to make sure I'll probably kind of spend
Mhm.
like the next like 5 minutes or so, just making sure I understand the problem, and then yeah, just clarifying requirements, things like that, if that's all right.
Yep.
Um,
Makes sense.
cool. So then if like we did something like this, the answer here would really be then 1 2. Is that accurate?
Yes, that's correct.
Okay. So cool. So the assumption is really you got to kind of find the proximity of each number and then return the pair that has the lowest proximity.
Mhm.
Okay. Uh, okay. So, and then I guess another clarifying question. We could always just assume it's always going to be binary, right? So like this wouldn't have a third, like it wouldn't be an area tree.
Yeah, yeah. There's
Okay.
going to be a left and a right. You can assume there's going to be like a left and right child.
Okay. And since it's binary and not search, I know I believe like binary search trees follow the actually this here where, well, not this bottom part that I added, but like this technically also I believe is a binary search tree. If you got the highest, I'm sorry, to the left would be the lowest or lower than the root node, and then to the right would be higher. So yeah.
Yeah, yeah. So I
Okay.
think given this example, it just happens to be in that
It's binary.
order, but there is no guarantee for the actual problem.
Got it. Okay. Um, okay. So yeah, I guess my initial approach would be, yeah. So there's obviously we'll have to traverse the tree. There's kind of two ways to go about doing that. So we could do breadth first search, and we can do then depth first search as well. Um, I don't know if there's like a pro or con to those initial approaches. I mean, breadth first, right? We grab the 4, and then we grab the 1 and the 10. Um, and then, if there was a third level, we'd go through that. Whereas breadth first, or I'm sorry, depth search, we traverse, we'd find the 1 and then the 10. So yeah, I guess my initial thought would be, yeah, I guess we could maybe start with breadth first search. And then the thought would
Sure.
be here. So we would have just in terms of like pseudocode. So we would have, we could do like a 4. So we, and then we'd get like a 110. Right. So it would give us that. And then if I think the one I added was like a 1 and 11. All right. I think I did 2 and 11. So we get that. And essentially, now what we can do with that is, we can then do closest elements in value. Okay. Yeah, so yeah, I guess pseudocode would be breadth first search initially. And I guess, yeah, just to specify this also would be kind of just a brute force. I guess we could talk about optimization and things, once a working solution comes. But yeah, since we were doing the traversal, yeah, my initial thoughts would be in terms of like time complexity and space complexity would be, time would be at least O of n, so it'd be linear because we'd have to at least traverse every node, since we need to know exactly the proximity of every node in there. So there's that. I guess I could write that down real quick too. So we do. I'm just going to specify this is just my initial guess. And then space would then be, we would need, yeah, at least an array to shove each node in. So at the very best, it would be constant as well. Or I'm sorry, linear as well. I think that might be wrong, but we can come revisit that again.
Yep.
Okay, so let's say we go through the breadth first search. I would get something like this. Now the question is, what can I do to this to find proximity, right? Because we know like these are neighbors. We know these are, oh, I'm sorry. So these are not neighbors. So these are not connected. So we would basically need to do, I guess to clarify, this really only works between like a parent and child, right? Like if this was 2, it couldn't be 1 and 2, could it? Or can it?
Yeah, it could be. So
Okay.
I guess proximity, where the location of the nodes in the tree is important. It's because it could be any 2 nodes in this tree.
Oh, got it. Okay, so okay, that helps. Got it. Okay, so I'm trying to think. Right, so I would get something like this. If they could be any nodes in the tree, I guess theoretically, you could sort this, right? If we sorted this, we get 1, 4. I'm sorry, get 1, 2, 4, 2, 4, 10, 11. Right, and then if it's sorted just in ascending order, you can just assume the first 2 would have to be it, right? Because it's already sorted. Some edge cases, I guess, to clarify, what happens if the tree is like only like the 4? Like if our tree is only 4, am I returning just 4 then? So if like
If that's the case, if there's only like 1 node in the tree,
yep,
then you can just return null.
okay,
Null or empty list should be fine. Either or.
okay. If I don't know, I'm just gonna say tree size is less than 2.
We can just actually just align on just returning empty list actually, and just make things easier.
Oh, okay. So just empty like that.
Yeah.
Okay, cool. Okay, so so yeah, I guess I think that approach would work, but and I guess to specify our return values. So like in this case, these are actual nodes, right? Or the value of the node. So would this be like
Those are
like
yeah, these
do
are actual values, so it's going to be like integer values essentially.
okay. So like if I just throw the root value into an array, that's okay here, or am I supposed to throw the root?
Yes. Yeah.
Got
Yeah.
it.
Root
Okay.
value.
Okay. Yeah. So I mean, I think this approach would work. I mean, you can do. So I basically have a nested array. In Ruby, there's a method called flatten, uh, which would then turn this into a single array, and then I just sort it, and then I can take the first two elements. Does that sound like a feasible approach, or no?
Yeah, I think that's towards the right direction. Yep.
Okay. Okay, cool. So I guess I'll start with the code implementation. So yeah, with any binary search, I'm sorry, breadth first search, I usually like start off doing like a helper function, right? So we're going to do find list elements. I'm guessing our parameter is just going to be the root. Is that
Yeah,
right?
yeah. So you'll just be passing the root of the tree, correct?
Okay. So actually, last time I remember, it's tough. So Ruby's supposed to do 2 spaces. I think this defaults to 4, so it's kind of throwing me off. That's all right. I'll just stick with 4 for now. So we'll do return. So we'll do oops. So it's well, actually, this might be overkill. We can actually probably do this all in one. Yeah, this is overkill. Here, I'm actually going to scrap this real quick, and we could just keep this all in one. So this we'll keep a queue. We're going to build the root inside the queue. We're going to say while the queue is not empty, we're going to get the queue size. Size, and we're going to do size. So here, yeah, I guess this to kind of clarify. So yeah, I'm just doing breadth first search. So yeah, basically the idea is you keep queue going, and then you start a while loop, and basically while the queue is not empty, you traverse essentially the node itself. So here we're going to traverse. We're going to create a essentially each loop inside the while loop. So I guess that affects my time complexity at least. Let's do that for now. We're going to take the current, which is going to be the q dot shift. So shift just pulls out the first or the next in line in the queue. Since this doesn't have any children, it's just left and right. We can say we're going to throw the side there, and then we're going to do so we're just going to basically throw if it has left or right values, then throw those into the queue as well. And then what we'll want to do is that'll keep the queue going, and then we're actually going to put results into. So this is just if temp set empty, that means we have a value. So this returns results, which I have up here. So then essentially here we'll return basically this thing, but we don't want that. When that sort. Let's do this. And then do so here we'll do the check to make sure there's at least 2 elements in here. So I'm sorry, we said so if there's even if there's 1 in there, we'll just return it's less than 2. Else we can return so in Ruby, the last line has an implicit return. So like this is the same as this. So I guess I could just keep that for readability's sake. But
yeah, thanks for explaining that.
Sure. Yeah. So I guess to quickly go over this or recap. So we'll do a breadth first search. We're going to just create an empty array out the gate and return that if root is nil to account for that edge case. And then, yeah, with breadth first search, we have a queue. We're going to add the root into the queue. We create a while loop that essentially goes as long as the queue has at least 1 value inside of it. Once we're in there, we're going to create a temporary array, and then that essentially represents each level of the search, and then we'll iterate through that as well. Here with this each statement, we'll take essentially the current root node, take its value, throw it inside temp. Since yeah, we clarified up here that root value is all we need. This will just return the values there. We'll continue to add to the queue if the node has a left or right value, and then we'll add that temp value, which is just an array of the values into results as long as temp's not empty. This should give us then like that nested array of something like this. I'll just stick with the original example. So in the case of like, this just being 4, right? So this case wasn't picked up because root technically wouldn't be nil here, but if there was only 1 value, this would just return the empty array here because the results, the length of the results array that we just calculated wouldn't be more than 2 there, and then this essentially would give us 1, 4, 10, which actually, sorry, that's kind of confusing. So this here goes to this. So what just happened? All right, and then this is essentially 1 and 4, since that's the first index or 0 index and then first. Actually, look at that. There we go. We actually want sorted results, not results, because results were not sorted. So, so yeah, I think that should work. I guess a question I have, like operationally, is how do I run this like without constructing the tree? Like, is that already constructed or no?
Running the tree. So I think in this case, I'll probably have you do a walkthrough instead of actually do do a run, but I think before we do that, I do see a bug in the program. I'm
Okay.
wondering, or at least in the solution, I'm wondering if uh, you can spot it before we attempt to try to run it or do walkthrough.
Sure. Yeah. No. Yeah. Okay. Yeah. Let's see. So, yeah, I know the first bug was there. So we want results. So, let's see here. Results. Return results. Is it like a logical bug or like a syntax bug? I guess is maybe a hint.
Yeah, it's only with the it's basically not returning the expected solution to the problem. So basically, I would say it's logical then.
Okay. Okay. So it's not returning the. All right. Let's see here. Well, Q is not empty. Temp is not equal. Just gonna do this. I know that's not it. I prefer length over size. Shifts. Current value. I guess to clarify, can we assume like this logic here, like this defines the node, right? So it's like I need value instead of val. Does that?
Yeah, yeah, it's not related to like
Okay.
something like that. That's
Okay.
gonna change the logic of your code.
Okay. We had Q there. This gives us results. Oh, let's see. That wasn't it, was it? This one here, where it was less than 2.
Nope, not related to that.
So the output is just one single array with values ordered. Hmm. I mean, I don't see like a flaw in terms of the output. I mean, I do see some optimizations. I'm thinking, I don't know if it's necessary to keep this temp array, but that
Sure,
I see is
I can try to help you out here. So,
okay.
what if we had something like if I'm still changing the tree up top? So, what if we had something like this? I guess what would your algorithm return?
Um, our outputs, well, the desired. Oh yeah. Oh, I see. Got it. Yep. So the output would be 4 and 5.
Yep. Or the expected output would be 4 and 5, but what would your algorithm return?
My output would still be 1 4, but it really should be 1 4 5, like that. I see. Yep. So yes, okay, that's a good call. Okay, so let's do this. So I think having a sorted array is still helpful. So up until this point, it's okay. So here, let me go with the new values. So we had 4 and 5. So this gives me 4 5. So yeah, we wouldn't want to just assume that. So now that we have a array, we can essentially, And I know this isn't performant because we have to do another iteration, but we can iterate through the array and count the proximities in between each. So like I could say like, hey, from 1 to 4 is 3, right? And then I could say from 4 to 5 is 1. So then we know to keep 4 and 5. Okay. So let's just say this. I'm just going to hard code this for now. Let's see. I could actually just do a 2-pointer approach. So it'd be my first pointer would be at 1, my second pointer would be at 4. I'd measure the proximity and then I would just move them up 1 each. Is that an accurate assumption or approach, or?
Yeah, I think, I mean, we're going to be having to compare the values in the tree. So yeah, I think that should be fine.
Okay. Okay, so I would probably just do, I mean, this method's getting fairly long, so I'd probably do like a helper method here of just so we know value 2 should be at least greater or equal to 1 since it's already sorted. So we can say value 2 minus value 1 is greater than proximity. Right, so this is going to be essentially, I'm just going to put this here. So this is going to be 1. This will be 4. So 4 minus 1 is 3, which is greater than 0. So we're going to set the proximity. All right, so let's go through logic here. This is going to be 4 minus 1, so which is currently greater than 0. So this is true. So our new proximity is going to be 3. And then our final results is going to be the value of 1, which in this case is 1 and 4. Right. So then we go through, we increment it again. So now this is actually going to be 4 and 5. 5 minus 4 is greater than 3. Oh, okay. This is the problem here. We actually want this actually less than. So yeah, because 5/4 is 1 and 1 is less than 3. This could just be, I mean, I would do like float. So yeah, we would just default the proximity to something, basically the max. So in that case, then it comes through. So then, yeah, the proximity the first time around would have been 3. So then proximity goes to 3, gets reset to 3, and then it comes in again. And now 5 minus 4 is less than 3, so 1. So then this gets set to 1, and then our value is 4 and 5. And then it increments, and then the second pointer here would be nil essentially. So it's going to be that. Okay, final results. Okay. Actually, I could just do that. Okay. I think that should work. Yeah, I guess just to kind of reiterate the logic here. So the idea is, as you pointed out earlier, right? My initial sorted solution is no good because I was basically making the assumption that the first two values would be closest, which obviously isn't right. So the additional step would be to go through and keep track of the proximity between each numbers, and since they're sorted, that should be easier to do. So then just created this helper method, initialized basically a 2-pointer approach, iterate through that sorted array that comes through. We're going to default the proximity to basically a max value, which is that in Ruby. We're going to keep track of this empty thing here, or I'm sorry, empty array, just so we always have a return value. And we're basically going to do that 2-pointer approach. We're going to use print iteration through the array, the sorted array that comes through. And then essentially, if the proximity is always less than the previously stored state, that it would reset and then just update those values there. So sorry, my son is screaming in the background as well. So
yeah, no worries. So yeah, I think this will actually work in this case now. So I think the only question I would have then is I guess going back to the beginning where we kind of went through the space time complexity, is there any updates you would do to any of those?
yeah, so yeah, this is definitely not performance. I would, probably we can actually probably just get rid of this temp array. I think we could just do this. So that gets rid of, that limits some space because we're not keeping an additional temp array that essentially gets added to as the queue builds. And then if that's the case, we actually then don't need flatten because we would just have one array. We would then have this there. And then, and then we, we have another iteration here. I'm trying to think if there's a way to bypass this. So if we have an array of that, yeah, I think, yeah, because then we use, extra auxiliary space here. We have the queue, and then we also have the results. I'm trying to think if at any point, I know like ideally, like if you can utilize like a hash map, that's usually ideal because then the lookup time is constant. But I don't know. I don't know if that's applicable here. Like if these were in like a hash, you'd still have to. I mean, you'd still have to iterate through them to check the proximities. And I don't know if there's a way around gathering the proximities without iterating.
Yeah, I guess that what I was actually aiming towards more was like X going back to line 13, 14. So
Oh,
just to clarify, is that O of n squared or O of 2n?
I think it would be still in. I think it was. Oh wait, sorry. This is for space. I think it would be 2n.
Okay. All right. Let's see. Yeah, I mean, let me check the time as well. Okay. I mean, we do have 15 minutes. We can continue. Have you continue, looking through optimization stuff, or
Sure.
could go into feedback a little bit early. Up to you how you want to spend the last 15 or the last 5 minutes or so before we go into the feedback.
Sure. Yeah. I mean, I'm fine. Yeah. Forging ahead.
Okay. Okay. Yeah.
Yeah.
Cool. So if that's because you can try to spend the last 5 minutes on optimizing, and then we can set some feedback then.
Okay. Yeah. So I kind of did. Yeah. Some optimized by getting rid of the temp auxiliary there. Yeah. Usually with optimization, also want to make sure like all our variables are actually named properly. So I mean, current isn't really, maybe, yeah, I don't know. We'll call this queue size. Actually, I mean, we could probably, I don't know if that, I don't believe that really improves like readability a whole lot. So we can just do queue that length. That way we can just get rid of this. Get rid of that line there. Queue, sorted results is accurate. Sort results, something, find proximity. Yeah, I don't know, find proximity. Maybe make that a little more descriptive here. I don't really, we'll just, yeah, this is kind of more like TypeScript where you're kind of more describing the value being pressed in. I don't think there's like huge benefit here just in terms of readability, but do that. This one, proximity. So that's, yeah, I mean, I guess I'm all right with like current variable names. I think readability was improved by like splitting this out to like a helper method. Like if this was included in that, this like that method would be pretty large. Yeah, in terms of like enhancements, in terms of performance, like I said, I guess, yeah, not to sound repetitive, but I currently don't know of a way to how I'd go about finding proximity without doing another iteration. So I don't know, like if I can do much more in terms of refactoring, iterating here. I mean, there's, you know, a different approach I can do instead of 2 pointers. I can just say like, hey, use no pointers and then do like a, you know, like a sorted array that each with index. And then, you know, I could basically then wrap that logic in here, and that might clean up some of this. But yeah, in terms of like performance, it does much. And then like in here, I would just check to make sure the index doesn't go over the value of the array length. But yeah, I basically use like the same logic here, where I'd have access to my current value, and then you know, the next index. So I would do, you know, something like you know, my second value would be, you know, sorted array, you know, index plus 1. But yeah, like I said, I don't think that has any bearing in performance, and some would argue it's more readable. You could also argue that it's not. So I know like people coming probably from like a JavaScript background or something might prefer, you know, a while loop. So yeah, I don't think there's much benefit to doing that.
Cool. Yeah, we can actually probably step into some feedback if you want.
Sure. Yeah.
Cool. All right, now that we do have about 10 minutes left, and I think we can wrap up here.
Sure.
But yeah, let me pull up my notes really quickly just to make sure I have everything summarized. All right. Starting up top, I thought it was pretty good that you were clarifying the requirements, or basically not requirements, but clarifying the input in the problem. I think that was like a pretty good exercise in understanding like what you're working with. You had the correct space complexity, but I don't think the time complexity was right due to like the sorting that we had. So maybe just take some extra time after coding mock interview to kind of take a look at that. Let's see, you were able to actually come up with an algorithm, but I think along the way on the coding, it looks like the code wasn't basically aligned with the algorithm, I guess, a little bit, since it was just literally just returning the first 2 elements of the sorted array. So I guess maybe make sure your algorithm is maybe a little bit more fleshed out, so that way you don't run into a situation where, okay, I'm just returning return the first 2 versus the 2 closest. I did like that you took some time to explain Ruby syntax for me, knowing that I'm not too expert. So I think that actually shows that you understand the code in your language. So I'm gonna keep that up. There was that kind of bug that we saw, and you unfortunately you weren't able to identify it on your own, but with a little help, I think you were able to at least do the fix on your own, and at the end come up with a working solution. So I think that's totally fine. Communication was pretty good throughout. There were a couple of instances of like prolonged silence, but not in my mind. It wasn't too big of an issue. I think for the most part, I would say it's generally well communicated throughout the interview. Given time to optimize, you did add some slight optimizations, but I guess one big optimization that you probably could make, not super big because it's still technically the same type complexity, but maybe you can do like 1 pass through the array versus like 2 passes. And that would be like the only thing there. But yeah, that is kind of like the assessment that I got in the feedback I collected during the interview. So is there any questions specifically about the feedback that you had?
No, that's great. Yeah, no, much appreciated. Yeah, I think, yeah, just my initial critique of myself is, yeah, that was a pretty big bug, or pretty big assumption, wrong assumption of taking the, you know, first 2 values and just assuming, you know, that those were true. So yeah, that was, yeah, thanks for pointing that out. And then yeah, once that was pointed out, yeah, I felt like it went a little better after that. And then, yeah, also that's good call out with the time complexity. So like with this sort method here, like Ruby out of the box defaults to like a quick sort, basically. So the quick sorts, yeah, I think would supersede this. And yeah, I'd have to go back and check. I'm pretty sure. I mean, it's been a long time since I've done
Yeah, I think
sorting stuff.
yeah, that's right.
Yeah.
So yeah, in login
Okay.
is the correct one. So yeah.
Got it. Okay. All right. Thanks a lot. Appreciate it.
Yeah. Hope you have a good weekend. Take care.
Thanks. You too. Bye.
Yep. See ya.